Well, hello and welcome to Chapter 8, Section 1. So, this first section, 8.1, is going to be percents, sales tax, and discounts. So, we're starting our financial section. Okay, so how do I write a fraction as a percent? What is a percent? How do I write a percent as a fraction or a decimal? And all those different pieces. So, the rest of this chapter, you have to work with the percent. So, we got to start with reminding you how to work with the percent. So look at this. We have what is a percent, right? It's the results of expressing a number as part of 100. Or you could think of it as out of 100, right? So 100 being our key word. If there was 100, how many did you get? We're always hoping for like what, 90 on a test, right? And that means you did really well. You got an A. So express a fraction as a percent. So our first section here is expressing a fraction as a percent. So there's a couple ways we can do this. It kind of goes through a little bit of rules here, divide the numerator and then multiply by 100. So there's the easiest way. 5 divided by 8 times it by 100. So you just get out your calculator, right? What is clear? 5 divided by 8, 0.625. So this is the same as 0.625. And then to get the percent, so a decimal to a percent, you move the decimal 2 places. I'll write that here. Decimal going to a percent. You move 2 decimal spots. And in the way, I mean, it's alphabetical, D to P, you go to the right, right? So this would become 62.5%. So all these numbers are the same thing. 5/8 is the same as 0.625, which is the same as 62.5%. They are all exactly the same. So the way that we get there, and we just have to be careful. Well, the way that we get to the percent could be a little bit different, but in your homework for this whole entire chapter, you're going to have to move a decimal to a percent. Maybe not a fraction, sometimes a fraction. Another way you could do this is you could think of this as how many out of 100, and you could do a proportion to solve. I know that's not what the directions say, but we could do this. So it would be 40 times x, or 40x equals 100 times 1. Divide 100 by 40, 100 divided by 40, and I get 2.5. And that is a percent. Okay, the other way is divide 1 by 40, and that would have given us 0.025. Move the decimal 2 places, we would have still got 2.5. So you can use a proportion if that's the way you like and the way that you learned. Okay, so if I take 13 and divide it by 80, I get 0.1625. And then I got to move the decimal 2 places to the right, and I get 16.25%. All right, so D through F is pretty much the same thing. You're just going to move your decimal 2 to the right to get the percent on each of them, right? So this is 0.47%. This is a 1,000,000% here, right? That's a big old number. 1,963%. 100% is one whole, so you're getting way more than one whole. Okay, and then 0.3844, move your decimal 2 places, and I get 38.44%. So going from decimal and fractions to percents, you'll be doing that every single problem this whole entire chapter. All right, express a percent as a decimal. So what if we want to go back the other way? So a lot of times, excuse me, a lot of times the problem will start with the percent and you have to put it in decimal form to be able to do the calculations. So for this one, you're going to move it this way, right? And you're going percent to a decimal. and that is 2 places. Always moving at 2 decimals. So right now, this is 19 point, right? That's where the decimal is. But this time we're moving it to the left because we're going percent to decimal. So 1, 2, and I get 0.19. So 19% is equivalent to 0.19. 180% is more than 1. So when I move that decimal, remember it's right here. It's 1, 2. So I get 1.8 is that number. Ooh, 1/4%. What is 1 divided by 4? It's 0.25. So this is the same as 0.25%. 1/4% makes a difference in really big loans, like a car loan that's 7 years, which is common now. It used to be 5. Now they're like so expensive. It's a lot longer. And or a house loan that's 30 years. 1/4% could end up being a lot of money over 30 years. So it does make a difference. And to write this as a decimal, you're still going 2 to the right, and you have to add 2 zeros to make that number work. 0.0025 is 1/4%. Okay, here's one more that kind of went on the other page, is 100%. So same idea, what is 1 divided by 100? That's gonna be 0.01%. Move that decimal 2 places and I get 0001. So move it 2 places to the left. So that's a super small amount. Okay, and then many percent applications are based on the following idea, that the answer is equal to the percent times B, where A is a percent of B. Basically, I guess that's, I don't know, that's from the book, but maybe it's easier for me to just say you're usually timesing your percent written as a decimal by a number to get the part. And the part is that A. A is a percent of something. So if I want to know 80% of 100, right? Then I'd take 0.8 times 100, and that would give me the A. That's what that's trying to tell you. And the same formula can be a proportion. But let's look at some examples. Suppose the local sales tax rate is 7.5%. You purchase a bike for $894. How much tax did you pay? So what is 7.5% of 894? When I say of something, I want you to think times, of times. So I'm going to move the decimal. I know 7.5% is the same as 0.075. I can't work with a percent, I can work with a decimal. So I have to change it to a decimal. And then the of means times. So I'm going to take $894 and I'm going to times it by the 0.075. That's going to give me 7.5%, which is $67.05. Okay, so I just move the decimal over 2 places, right? And make a decimal, move the percent decimal, right? Over 2 places to make a decimal and then times. $67.05 is 7.5%. Okay, so now what is the bike's total price or cost? Do I pay the tax or do I get to subtract the tax? I have to pay it. So the price is $894, and then I have to add $67.05 to get my total cost of this item, $961.05. All right, example 4. Suppose the local sales tax rate is 6%, which is what ours is, and you purchase a computer for $1,971.60. Again, how much is your tax? All right, I have to write the percent as a decimal. So I need to write that as 0.06. 2 places to the left, right? And then times by the 1971.60, and that's going to give me 6% of that number. So 0.06 times 1971.6 is 118 well, it's 0.296, but that's going to round it to 30. Um, 30 is, no, I got it here, 30. I don't know. Okay. All right, then from here, what is the cost of the computer? Including how much is, what is the cost of before tax? What? Oh, shoot. I read the problem wrong. That's okay. We're gonna do this problem twice. What is the cost of the computer before tax? We're gonna say with well, stinkers. That's what I get for just going with. All right. This, what I looked at is this is our price. Ah, bummer. Let's just erase this. Let's try again, Charity. Suppose the local sales tax rate is 6% and you purchase a computer for this, including tax. I didn't even read this. So then I looked at my key and was like, what did I write? So I didn't have to put in my calculator. All right, whatever. You can get your tax by moving the decimal, but what do I do if the tax is already included and I want to know what I paid for it? This is a good way just to make sure someone's charging you the right amount. A lot of companies now kind of sneak in some hidden fees. So, all right, how much is this? So let's think this through. If we let X equal the original or the price, right? The computer price, original price before tax, then we could think of it as we take that and we add it to 6% of that amount. That's kind of a little bit hard to think of. And that would have to equal the 1971.60. So I know that I times it by 6% and then I add it back to the original to get to that price. So this is going backward. So if I add 1x plus 0.06, I get 1.06. Now, some of you could start at this step. And you can start at this step because you think it's 100% one whole plus 6%. So some people can start there and then divide over and see what you get. So I'm going to take 1971.6 and divide by 1.06, and I get 1860. Okay, so I'm going to take X is going to equal the 1971.6 divided by 1.06. And that gives me 1860. And we want to know how much the tax is. So this is the answer to this one, right? That's our price. Our tax would be to subtract the 1971.60 minus the 1860 has to be our tax, right? Because that's our price and we got to subtract to get our tax. So our tax is $111.60. All right, so I can work backwards. It's a little harder, but it still is important to be able to work backward and read the problem right, that it says including tax. That's all right. Problem 5, a computer with an original price of $1,460 is on sale for 15% off. What's the discount? What's the price? So now I have a discount. So instead of adding it, I'm not paying tax, I'm getting a money off. So how do I figure it out? Same way, 15% of 1,460. So 15%, write that as a decimal and times it by 1460 to get your discount. Right? So I get a discount of $219. Kind of a cool rule of thumb is if you move the decimal one place, it's 10%. So that could help you at the store. Move the decimal one place is 10%, so I'm getting 10% off, or 20%, I would double it, or so forth. Okay, so what's the new price of this item before tax? Would be $14.60, and I get to now subtract the discount because I'm saving that instead of paying it. Now our new price is $1,241. And if this problem didn't ask, but if it then asked for tax, then excuse me for a second. If it asked you for tax, you then now would calculate the 6%. You cannot like subtract a percent in the tax and get a new, like, and do it in one step. 2 steps have to be done if you have a discount and then tax. So if I wanted to do tax, right, I would then take $1,241 because I'm not paying tax on that full amount. No, thank you. So then I'm going to times that by our 6%, which is what we have in Wyoming, go up to Billings, and then you can have no sales tax. And then times that by 6%, and I get $74.46. So then I would then take our price we were at and I add my tax back. So it would be 2 steps to get that final amount if I had to pay tax and I had a discount. So there we go. This would not be the same if I took 15%, subtracted 6%, and tried to do it in one step. 2 separate steps, and then you'll get the right answer. Because I only want to pay tax. I want the discount of the full amount, and I only want to pay tax of the discounted price. Okay, moving on to another idea. This is called the percent of increase or decrease. So what happens if I buy an item and I know I paid $30 for it, and the original tag said 50? What percent did I actually get? Was it what I was supposed to get? Like, how do I know? And this is this idea. So to find the percent that you're increasing or decreasing, you find the amount of the increase or decrease. So here it's saying find the amount of the increase or decrease, and you divide by the original. So this is a subtraction to get here. How much did I go up? I subtract. How much did I go down? I subtract. Okay. So, and then I divide by the original. So let's look at a problem. Find the percent of increase for, fraction in step 1 is a percent. I'm going to skip that. Find the percent of increase. I don't know. Step 1 as a percent of fraction. Step 1 as a percent. I don't know what step 1 it's referring to. Let's just go like this, and we'll just say the percent of increase. I guess we want to keep that piece there from what did I say a minute ago? A price of what if I did it like $30? Find the percent of increase or price decrease, or price a fraction, and step 1 is a percent now. If original price is $50 and I paid $30, what was my percent of increase or decrease? So first of all, if I go and the tag says $50 and I go and I pay $30, was it a decrease in price from the original or an increase in price? So the original price is $50 on the tag, so I went down. So it definitely is a percent of decrease. We went down, not up. And then what is it, our increase or decrease? We do 50 minus 30 divided by the original, which was 50. Okay, so you subtract to get the percent or amount of our decrease. So 50 minus 30 is 20 over 50. Take out your calculator. What is 20 divided by 50? I get 0.4, which is equivalent to what percent? Move your decimal 2 places, and that's the same as 40%. So my percent of decrease was 40%. So I saved 40% on my item. Sorry, I didn't like the idea of making all those percents going down. So problem 6. In 2000, the world population was approximately 6 billion. The graph below shows the world population projections through the year of 2150. The data are from the United National Family Planning Program and are based on optimistic or pessimistic expectations for successful control of human population growth. That doesn't sound very nice. Find a percent of increase in world population from 2000 to 2150. So 2000 to 2150. And for the high projection. So that's this one here, right? So we're going from 6 to 30. Okay, so we're going from 6 to 30. So 6 is original, 30. You have to think that through. So when I go to do this, I'm going to subtract them. I don't care which way we subtract, just do it to where it's a positive number. And we're dividing by 6 on this one because that's the original. So 24 divided by 6 is 4. What is 4 written as a percent? Here's the decimal, move it 2 places to the right, follow the alphabet. Decimal 2%. So it becomes 400%. 4 times the amount is the high projected of population. Okay, for part B, find the percent of decrease from 2000 to 2150 for the low projection. That's going to be this one. We're still starting with 6 million, but we're dropping to 4 billion. Oh, these are all a billion. I keep saying million. So 4 billion. So we again are going from 6 to 4% of decrease. The other one was increasing. I should write that word here, increase. Okay, and so this one, again, just subtract your numbers, divide by original. 6 is still our original. So I get 2 divided by 6, which is like 0.3333 repeating. If I write that as a percent, I get 33.3%, and this is a decrease. Okay, so one was a high projection and one is a low projection. One's an increase, one's a decrease. Example 7, if increasing from 2 to 8 is a 300%, then decreasing from 8 to 4, a 300%. So if increasing from 2 to 8 is 300, is that going to be the same? Well, let's look. So 2 to 8, I'm going to go 8 minus 2, divide by original, which is 2, because you're going from 2 to 8. So this is going to give me 8 minus 2 is 6. So 6 divided by 2 is 3. Okay, that gives me 3 or 300, right, percent. Over here, we're still doing 8 minus 2 for the top, but we are going from 8 to 2. So 8 is what we divide by. So 6 divided by 8 is going to give me 0.75. Move the decimal, and I get 75%. Are they the same? No. So because they're based on the original amount, you can't switch them and say they're the same. If I'm increasing from 2 to 8, that's a 300%. But if I'm going from 8 to 2, it is a decrease of 75%. So kind of weird, but it is the way it works. Okay. I guess it's not weird. It's just, yeah, looks a little bit different, but oh, here's the problem. 8 is like the one I made up. We'll skip 8. So we talk about abuses of percent. So percents are abused all the time. All the time. People say percent's wrong. They just add in their own percent. They just throw a percent out at you, and it's not even off anything important. So very much you can have some abuses in percents. So John Tesh, while he was co-anchoring Entertainment Tonight, reported that the PBS series The Civil War had an audience of 13% versus the usual 4% PBS audience, and an increase of more than 300%. Did he report this correctly? All right, so he is saying we went from 13 to 4%. So audience of 13 versus the usual 4%. Which one's the original? The usual 4%. So we're going to divide by 4. So 13 minus 4 divided by 4. And I know this is in terms of percent, but just think of it as 13 and 4% divided by 4. So 13 minus 4 is 9. 9 divided by 4 is 2.25. That as a percent is 225%. So no, he is wrong. That is not 300%. He is wrong. All right, and if you did it in decimals, you'd get the same answer, which is totally acceptable. 0.13 minus 0.04 divided by 0.04 is still 2.25. So you're good either way. Because I would have probably thought of it in decimals if I was a student in this class. All right, a politician states, if you elect me to office, I promise to cut your taxes for each of my first 3 years of office by 10% each year for a total of 30%. Please vote for me. Okay, what's wrong with his logic here? 10% each year, right? So let's think this through. Let's just use some money. Goodness, let's just think of like we have let's 1,000. We're only going to make $20,000 a year. My income should be close to what or under if you're in college. Okay, so then that first year, you're getting 10% off. So 20,000 times 10% is going to give me, move the decimal one place, that's all, $2,000. Okay, but then the second year, I'm the next year my taxes are already down some. So 2,000 times 0.1 is sorry. Yeah, move the decimal one place. It's 20,000. Oh, never mind. So now at the second year, what am I starting with? I'm starting with 18,000 because we made the 2,000, but we're saving that money. I think when I'm giving my example, I'm thinking of paying those taxes. I'm like thinking of it a little bit wrong. But the second year, my whole point was the second year, you are not at 20,000, you're at 18,000. Like the tax will change each year. So the total is not correct. So then it would be 100. I'm just going to keep going with the way I know that I'm not quite thinking of I'm not doing it wrong, but I'm not showing it like how it would actually kind of evolve. But so if I'm making 18,000, then what is 18,000 times 0.1? Move the decimal over, and now 18,000 or 1,800 is my tax. So I'm going to subtract that from 18,000, and the following third year, I'm now going to be at 16,200, and then times that by the 10%, and I get 1,620. And from that, it's like, where would I be at that point? I would be 1,600 minus 1,620. At my end, right, result would be 14,580. So I'm going to percent, instead of calling this my income, I'm going to say my tax that I pay. Then it'll make sense. I was like, it can't be your income. Like, your income would be going up if your taxes are going down. I'm like thinking of it a little backward. Okay, so the first year, no matter what I'm thinking of, think of it as your terms of your tax. If I'm paying 20,000 in tax, then you know, it goes down 10%, I save $200. And then the next year I'm only going to pay 18,000. So 10% of that, I save more, right? And then I save more. So overall, now I'm at only paying this much money. If I take that much money and I divide it by my original, I can get the percent of increase over the 3 years. So divide that by 20,000, and I get oh, I forgot to subtract. Hold on. I was like, yeah, no. Do it a little bit backward. We're gonna take, well, I don't wanna, this is 1458, 1458. Let's write like this. 20,000 minus 1458. Did we say it was 14,580 divided by the 20,000? Because I need to think of it as, I know 14,580 will be my tax at the end. So that is a total savings of $5,420, and divide that by 20 to see the percent of the original. And I get 27.1%. Ooh, it bounced weird on me. Okay, percent. I must have hit this little arrow thing over there. All right. So is that equal to 30%? No, because it would change, and you're taking 10% of the new amount, of the new amount, of the new amount. So that's not going to be 30. It's going to be less. So he lied to me. Well, first of all, no one elected can ever cut taxes by 30%. Okay. And if they did, then my parents would no longer have Social Security. All right, so this next one. Determine whether each statement makes sense. Explain. I have $100 in my restaurant bill, comes out to 80, which is not enough to leave a 20% tip. Ooh, so my bill is 80 bucks. I only have 100. Can I leave a 20% tip? So we could take our $80 and times it by our 20% to see what that tip would be, right? For 20%. So if you're at a restaurant, you can times by 0.2, or again, you can move the decimal one place and double it. So move the decimal one place, that's 8, double that, that's 16. So I need to leave $16. Do I have enough money? I have enough. I have plenty for the 20% tip. Okay. I found the percent of decrease in a jacket's price to be 120%. Okay, so I went and looked at the tag, and then I go up and I pay 120% less. Tell me what's wrong with that. 100% is all of it. They're gonna pay me 20%. No, I would earn money. They're not gonna do that. Paid 20%. of cost. No, they're not, you're not gonna, no, not gonna happen, right? You're not gonna earn money by going and buying a jacket. Okay, my weight increased 1% in January, 1% in February. So my increase in weight over 2 months is 2%. We just did this one. It's not going to work out, right? It's the same as tax and discount too. You can't keep doing a percent because the number changes to add it. So if my weight increased by 1%, now I have this new weight to increase again by another 1%, which is slightly more than 2%. So nope, doesn't work. And you could do an example and say, okay, what if I weigh 150 pounds? What's 1%? Add that, you get your new weight, 1%, add that, and then you can figure out that percent of increase to see if it really is 2%. It'll be 2.1 or so. My rent increased from 20 to 30% of my income. So the percent of increase is 10%. What's wrong with that logic? Again, like, we have to, if it's increasing from 20 to 30% of my income, so my rent increased from 20 to 30% of my income, so the percent of increase. Let's just do it real quick. So my rent increased from, so 20% to 30% of my income. So what's our income? 50,000? Okay, sure. I could have done the 20. So that's our income. Let's see what happens. Doesn't matter what we make up and do the problem with. It'll still be the same whether I started with 10% or $10,000 or whatever. So it increased from 20 to 30% of my income. So I'm going to take 50,000 and I'm going to times it by 20%. And I'm going to take 50,000 and I'm going to times it by 30%. What does that give me on each of those? So 50,000 times by 20% is 10,000. And 50,000 times by 30% is 15,000. And so the percent of increase, so the increase is 5,000 between the two, divided by the original, which would have been 50,000. Okay, so 5,000 divided by 50,000 is 10%. Oops, 0.10, which is 10%. Ta-da! Sorry, I couldn't explain that one very well, just out making up some numbers and playing. So probably similar for a lot of people to figure out whether or not they're true or not. So that one, if my rent increased 20 to 30% of my income, the percent of increase still is 10%. Okay, because it's still of, I guess you think of it as it's still of the same amount. The 50,000 didn't change, like it wasn't affected. Like your weight, when it increased, your new weight is different. So then when you do 10% again, it's going to change and be different because the weight was going up each time. All right, that's the start of this section or chapter.